Welcome to Snark Chocolate, a show about ZK products where we break them down with rich flavors and sweet insights. My name is Omer and I'll be co-hosting this episode with Queenie. Today, we are about to get space-filled with Matej and Daniel, the founders of SpaceCoin. SpaceCoin is a new and secure protocol between satellites. It has many applications, both terrestrial and extraterrestrial. So guys, first thing first, how about a short intro? How did you get to work on space technologies and how would you define SpaceCoin?
Sure. So I guess space is actually a new frontier for me as well. It's not a space that I was familiar with before, but I was involved in the crypto space for about the last 10 years roughly. And one of my dorm mates from back in Technion in Israel, Jan Michalewski, he went to study in Stanford Applied Cryptography, and we kept in touch over the years. And he started a project called CryptoSat. And at the time, I was in venture capital, and I told him that whatever he's doing, I'm going to support. And he came up with this idea with another mate of launching into orbit crypto engines aboard satellites and using them for cryptographic applications. And this was DeFi summer. So when they asked, is this idea fundable? I said, we should not exclude aliens from financial services. Someone needs to build the infrastructure for alien banking, space banks. And that project got started. And since then, quite a lot of interesting experiments and applications were tested using those satellites. And Matej actually was an angel investor in that project formerly called CryptoSat. They rebranded recently to Aptos Orbital, although nothing to do with Aptos network. So Matej has been an angel investor in the CryptoSat project. I was an advisor, and as the years gone by, we both fell in love with that concept of building a extraterrestrial distributed space computer. And when the stars aligned in a particular way, we basically decided to jump on board and take a lead on starting a proper protocol project. And I guess Matej, share your view there, because you actually do have more space background than me. I somehow got into this project from the crypto side, but the space background actually Matej has a bit more of.
Okay, yeah. I think my space-related things are circling back to something 2014, 15, when I managed to get in touch on the ESA Earth observation thing. So we've been participating in the Vienna hackathon back then. So that was one of my first on-hands ways to touch these assets, where we've been participating doing the Albedo hackathon. And then I got in touch with the local guys from the local Slovak Space Association, shortly SOSA. We're actually been launching the CubeSat, and we've been helping them write the proto version of some software for the ground stations. So that was I would like to say the first touch on these kind of things and the telemetry. Unfortunately, their satellites crossed some South Atlantic anomaly after 3 months after launch, and after many months of delays of early SpaceX launches. And then fast forward, I started doing something else in the crypto space, obviously. And then I circled back just around 2019 with the idea figure out finding the business model on the tons of the data sets, where we called the project the Star Mesh, and we tried to apply to the ESA incubation, but we failed. But they actually find my article on the internet and get back to us to offering some money. But I wasn't focused that anymore. And then, there was something around the peak bull market. I was happy to angel investing. And Daniel came with this, the CryptoSat guys. I was this is actually space race, so it's coming back. And I just decided to invest. So that was 2022, if I'm right. And yeah, circling back, early this year, like 2024, was the chat with the Daniel that actually there is the idea to pursue the original idea of the CryptoSat, where the Aptos Orbital actually went to pursue like more legacy business models, I guess. We actually try to bring this back to the markets. So I think that's a brief story how to get to those things.
Great, thanks for the intro. I want to make sure we are like crystal clear on the vision. So maybe you can just give us some kind of like your view on what's the end game for SpaceCoin.
Okay. Wow, endgame. I mean, there is everything is revolving around the space-based data centers. So there's actually things like you can run the computation instead of the Earth on the orbit. And there was like recently this year around the summer published a study that actually as the human civilization we can do much better. And the current data centers are not most feasible things we can do. And running it on the orbit, we can actually save a lot of on the cooling costs, and we can save on the accessibility of the solar radiation. So for powering energy, this kind of the silicon chips up there. And if it's all this balanced well, we can build sort of mega constellations that are around the Earth for much cheaper operating costs. So this is actually kind of the baseline division out there. And once you actually figure out these things up there, I think there is many such cases which actually adds the extra security layer for all the terrestrial blockchains we currently have. So yeah, that's something we actually see like if the Bitcoin was like the computer for the money, and Ethereum is becoming like the world computer, we see the space coins as the space computer, where actually we can do computation outside, and it can offer like much higher sense of the security in the theoretical things, which we actually obviously want to like factorize and quantify, and to demonstrate actually that it's not. It sounds as crazy idea, but until we actually demonstrate in the numbers, it's not, and it's becoming the more materialized.
Yeah, I think this like last bit is very much capturing the meta like vision, if you wish. Like Bitcoin started as money computer, like distributed consensus based money computer that turned into a gold computer more like, and Ethereum came with this Turing complete distributed consensus network, the Turing complete world computer. And then as it becomes very clear that the space frontier is, it's no longer like a sci-fi thing, it's actually like a necessary frontier for the future and for some immediate applications. I mean, my connection currently is Starlink, right? There's one example there. So the space computer is like, it's a very clear necessity, because if we don't build for a open space native economy, then it's just going to become like yet again a closed source and like centralized economy. So permissionless space computer.
Right, that sounds exciting. Let's bring it down to the ground level. No pun intended. Um, can you give some use cases, short term, medium term, long term for this type of network?
Yeah, so I guess like maybe just as an umbrella thing, something that is becoming quite hot topic in crypto right now is programmable cryptography as like an umbrella term for a lot of the schemes like MPC, ZK, etc. And in some respects, what we have with SpaceCoin is essentially a space TEE. And actually, it was recently shown in, I think it's the um, Gakonst, can't remember his name from Paradigm, Gakonst. Uh, he showed,
Georgios,
what's that? Georgios, yeah.
George, yeah.
Georgia. So he was showing the hierarchy of secured hardware and TEs naturally like being a big part of it. And I remember that in the T Salon recently in Bangkok, so he was mentioning that actually the space TE pretty much um, fulfills all of this plus. So it actually exceeded even Gakon's table, and it was showing up in automata hierarchy of TE is there. So in some respects, having this space TE and the layer is a layer for programmable cryptography or programmable cryptographic applications that then many of the MPC use cases, different key management schemas, bulletin board, cosmic randomness, many of the applications that are already enabled are very practically relevant today, not just the futuristic use cases. So, but yeah, Matej, like it seems like you had some use cases to bring besides.
Okay, I think the use cases the brainstorm is obviously like what the CryptoSat team demonstrated, like using the multisig. So they demonstrate broadcast the transactions from satellites back to the terrestrial chain. I think that was done like with the defense and Zengo, if I'm right, for the custodial solutions. And from there, we actually have exposure for the radiation from the sun, because the atmospheres actually capture most of these cosmic rays coming through down to the Earth. So we can actually have exposure to much higher grade of the entropy and the randomness you can get down here on the Earth. And we thinking about it could be like one of the other products we actually can offer with the SpaceCoin for various randomness where it's actually required for the handshakes, the cryptography and whatsoever. Another thing actually that's just very recently, which actually need to validate, is actually the checkpointing for the various long-range attacks, which I think is not so unreal in the future for the L1 and L2s. And other things actually which might be real in the upcoming years and the launches is like something we can offer alternative for GPS system to prevent some geosibils. So we can like offer accurate position because we obviously know positions of our satellites, and we can figure out like the alternative for the nowadays GPS jamming and on the crypto networks to misreporting their location to gaming the incentives. So this was the one of the things, and I think if everything goes well and we manage to accrue a lot of bandwidth, we can eventually do the active validations with the protocol, which we can accommodate it on our hardware, obviously. So yeah, that's one of the things. But I think many other use cases will come along as we will be having hardware out there, and the more demand and more crazy inquiries we'll get over the time.
I think it would be helpful if you guys can walk us through the structure of the product first, so that maybe the audience can better understand the use cases. For example, I saw there's a layer 1 and layer 2 structure.
Okay, currently, how the infrastructure looks like is like that we are using, thanks to the Aptos orbital, we are using the Iridium network, which consists like 66 satellites with the 9 in the backup. And it's obviously now the current only one communication network, which actually in the future we will be agnostic to, and we can use the much better one too. And then on the units from the Aptos orbital, we actually can drive the computations itself. And thanks to the Iridium, we actually don't need to wait for the ground station to pass by the satellites over the ground stations, which actually takes like around approximately 90 minutes. And it's predictable, but the orbit probably repeats around every 2 weeks, I guess. And thanks to the Iridium, we can actually claim that we are almost online, as we can get response now currently around 30 seconds on median, and in the future that will be obviously instant, like you're actually using the Starlink. But I just want to like distinguish, like the Starlink is actually just the mostly mirroring the connection on the ground Earth, so it's like optimized on the connections between the ground relay station and their phased array you can have at home, where actually we are existing approximately 300 and 500 kilometers higher. So that actually we are actually requiring way different architecture to have. And this is actually how briefly communication works and the computation. And from there, actually, we're looking forward, thanks to having like the satellites and the reachability, we can start offering these nodes, I would like call it simplified, where actually people can either accommodate the protocol or their computation or execution, and they can actually drive their very own experiments with our network. So that's the briefly, very simplified version of it, I would like say. I think for more information, you can always check our blue paper. It's linked on our webpage, the SpaceCoin.xyz. And now actually we're looking forward to implement very easy protocol to communicate with the satellites back and forth. Maybe Daniel want to say something?
Yeah, I guess Queenie, just to follow up on your mention about the architecture for layer 1 and layer 2. So the way we went off with the design initially is understanding that space environment is slightly more constrained than Earth, to say the least. You're working under higher latency, lower bandwidth, so it's kind of different, right? What we wanted to do is, on the one hand, still keep this orbital root of trust as the key kind of the key advantage or selling point, if you wish, but also make the terrestrial blockchain application support performant. So we basically went off with a design of a capacity constraint equivalent network in space, the L1 celestial network, and then an L2, which we call it the uncelestial network, which essentially is on Earth and is able to then give all the relatively high performance support that you'd get from, let's say, like state-of-the-art scaling solutions today, be it the ZK rollup or other like commit chain implementations. We're actually evaluating a series of other, let's say, like bridges, AVS, like any kind of alternative to kind of scaling on Earth can eventually be a mirror for scaling from space to Earth, essentially. So then what the terrestrial user sees is what they're familiar with from typical performance, where there is a stage of pre-finality that happens on Earth, and then the final finality that ends up being when the space network is from time to time being settled on. So very similar to how you'd see how layer 2s work here on Earth, just like mirrored out to orbit.
I see. Just like we sent Ethereum, the layer 1 to the orbit, and then layer 2 still stay
Something
in
like
the
that,
Earth.
yeah. Actually, like, quite a few of the people that it's interesting. After we published the blue paper, a lot of like crazy applications come and say like, so there's this one guy, Shumo, maybe you know him. He was like
Yeah.
saying you should send like the Ethereum Foundation should send all of their validators to space. That should be the strategy to future proof and stuff. So yeah, like all kind of crazy ideas come now. So yeah.
Interesting. So you actually just mentioned two metrics, the latency and throughput. So when we are, looking at the different blockchain um, components, then we always measure like whether it's decentralized, secure, censorship resistant, cost effective, or whether it has low latency and high throughput. So I'm curious here, like why SpaceCoin is so unique for the application builders. Like you guys have something that other ecosystems don't have, and probably that can enable some use cases that only can be built on SpaceCoin.
I guess this comes from the security, like the high security guarantees. So actually, one of the things that really inspired me in what we're building was the original blog that Omer wrote, the reincarnation of the trusted party. Because if you think about the innovation that is enabled by blockchain as a whole, so the root of it is in the trusted party setting. So if in the Web 2 scenario we had a centralized trusted party as Google or AWS or your bank, and then we moved to distributed trusted party, because like some people sometimes confuse and say that this is a trustless network or trustless protocol or whatever. It's not that it's trustless, it's that the trust is distributed, and therefore there's crypto economic security guarantees around it, etc. With SpaceCoin, one of the unique features is that the trusted party is not just potentially distributed with the redundancy given constellation, but also it's extremely hard to tamper with. And therefore you can start looking at a TE that doesn't have the same vulnerabilities that, let's say, Intel SGX or other TEs would have, because someone can potentially eventually leak a decryption key from the manufacturer, etc. So just by virtue of having this orbital trusted party, it suddenly opens up a lot of interesting applications that otherwise you'd not want to assume this level of trust in the hardware. And yeah, I guess like the application touched on earlier, be it the MPC schemes that rely on the satellite as being one of the cosigners, like secure co-processing of sorts. And yeah, the secure deletion was another thing that we discussed. So apparently it's very difficult to guarantee deletion of data. With the physical isolation and a proper proof of deletion protocol, we're able to guarantee that too. Yeah, there's various different applications of that sort. And also maybe important to mention that while this is a very hardcore, like nerdy style project and kind of something that appeals to the mostly the IQ 150 side, and the left curvers are still like catching on, we actually did get quite a lot of inbound requests from people that, oh, like I want to launch my meme coin from space, so this like will be a space drop rather than an airdrop, or people want to do a space mint like for NFTs, or there's like a space DEX, there's like anything you can imagine. People come up with like degen related ideas that are by all means welcome, because oftentimes these are the ways that, you know, the tools get tested, the water get like passed through the pipes, etc. And that's how we kind of like build it eventually and learn from everything. So there's actually quite a number of those that are in our pipeline of like following up with teams that want to do crazy stuff. Oh, like I mean, look at it's audio only, but look, my is covered with like space pepper related stuff. So
Yeah, I actually found it's very interesting because at the first glance, probably I feel, yeah, it's a meme kind of project. And then after I dive deeper, I thought, oh, it's actually super nerdy.
yeah, yeah. It's kind of like either for the IQ 150 or the 50. There's like it's not a mid project basically.
Nice positioning.
It's actually like super deep tech, right? I mean, there is this like security aspect, security by isolation, but there's also the compute part. So I guess in theory or in practice, you guys are supporting or would benefit significantly from adding more compute into space. And this, I think, aligns with the trend we see of indeed, like, you know, there's a lot of need in compute, and like they have all these different constraints. So we are expected to see some increase, and there are companies working on actually bringing more compute to space. Can you maybe elaborate more on how this can benefit you, or why do you think this is like, or even just, you know, more about this trend of getting more compute into space?
Okay, I think the main driver behind this is actually the price per launch is actually decreasing. So I think 2010 it was around 50K per kilogram. Now we actually dropped something around 10,000 per kilogram. And in the future, we're actually looking forward to be like at $10 per kilogram. And I think once we're actually going gradually there, a lot of people will realize that actually price per launch actually is getting cheaper and cheaper. And simply training your LLM on the orbit will get eventually cheaper as well because of the much lower operating costs. And I think that's the main thesis behind all of this. And I think like right now all the signatures and blockchain applications are way cheaper than any LLM processing, I guess. But eventually we see like there will be probably more and more computation out there thanks to this the economic constraints. So only thing is actually I think the good radiation shielding for the hardware. I think that's going the props to the CryptoSat team that for almost 4 years they did not occur any bit flip, which is actually quite a major achievement for the long period of time, because there is like a lot of small satellite companies who actually get bit flip in the first year or second most likely statistically. So having like the good battle tested hardware is like sort of everything. But yeah, in the cryptographic setting, I think you can always like figure it out things over or so in the terms of the cryptographic calculations, of course. And as we actually talking about the distributing in the swarm of the satellites, I think we can build something more robust in this way, which can like offer this storing your assets or your apps up there on the nodes, which actually could be like flexible. And yeah, apart from the cost for launching, there is another things like which actually plays a lot for this the space-based data centers is like you don't have any natural disasters which actually occur on the Earth a lot. And because like if you're choosing the data center where you place it, it takes like something close to 24 months to build it from some brownfield project, where actually with the satellites, once you have the hardware, you just book the slot with the rocket companies. And these days you've seen like the Pentagon deal they booked, and after 10 weeks from signing contract, they're already launching their proprietary cargo up there. So I think you can launch the computation in future like over next weekend or something like that. So that's actually really a special case, I would like to say. Another thing is actually, yeah, of course, the price. Actually, well, at least now you don't pay for any kind of the plot, but that's sort of the advantage of the early adopters. So I believe like once we get like a lot of specialized hardware, which actually can withstand some radiation levels, we'll see like the GPUs like H100s or H200 on the orbit, at least in the lower orbit, like around 200 kilometers, and then obviously higher and with more energy. And yeah, we chatted with one guy who actually already prototyping having the solar array about 20 kilowatts, which actually offers a lot of energy, I guess, already. So that's the currently future, which actually we'll be testing in 2025.
20 kilowatts, more than I have on my roof here.
Yeah.
I think also about the compute context there, Omar, is like space-based compute is already an important part of geopolitics and the economy. So you know probably Planet Labs, which are super successful space company that now a lot of people are relying on it, like be it intelligence agencies naturally, but if it's also energy and resources, mining and stuff like that, and you have more and more projects in that nature that obviously for them it's a clear use case, but it's becoming just more prevalent to think about crazy use cases that before the price was prohibitive. Now basically like even SpaceCoin, right? Like the SpaceCoin as a use case sounded completely wacky a few years ago, and now it's totally realistic to pursue it, right? So it's like the more the skies open, literally, the more just these use cases are possible, and then that economy, like that space-based compute, is opening to more ideas.
What about research? Usually in deep tech, we have a lot of open research questions. I also saw that you have some people with heavy academic background that are drawn to the project. Maybe you can share more a few of the interesting research questions these guys are trying to solve.
With regard to the academic and research background and context in SpaceCoin, yeah, it's because of the nature of like the sci-fi-ish nature of the project. A lot of the top quality nerds are gravitating to it, and we're very fortunate to work with Professor Dalia Malki from UC Santa Barbara. She's a total rock star and innovator and inventor in the consensus and cryptography world. Actually, she's been the first person that implemented multi-party computation, I think, between Hebrew University in Jerusalem and New York at the time, two-party. And yeah, she's basically from even before we started working on the protocol, she was just like, this rosy-eyed, but at the same time very pragmatic. She was saying, I've designed consensus protocol in traditional distributed systems. I designed consensus protocols in crypto and decentralized systems. I never designed a consensus-based system in extraplanetary environment, and that's a very exciting scientific challenge as well, because suddenly you're working under a completely different environment, very very constrained essentially compared to what you have in today's internet, and that forces different design choices, and yeah, that basically brings up a lot of questions that we get into deep rabbit hole as we're exploring what kind of protocol specification are actually going to be pursued, etc.
Research also means, in a way, risk. So I was wondering if what would you mark as significant challenges in the roadmap that you need to overcome?
That's a great question. I guess in some respects I agree with that research means in some essence uncertainties, because you're working on things that are cutting edge and there's open questions. At the same time, I would argue that in crypto, a lot of the meaningful projects that are most relevant commercially as well are very strongly based on constant incremental R&D that is pursued there, and be it like the basic, I mean, you've been in wallets that are considered now commoditized, but still there's so much innovation to do in how wallets function, right? Or be it like the deep cryptography, or in our case some aerospace distributed systems, whatever it is. It's like crypto is actually filled with research anywhere we look at, if we actually look at carefully. So yeah, while there is this risk, in some respects it's just an inherent aspect of what crypto is, and actually it's a cool thing that it's also constantly being connected to free markets with feedback loop there. But yeah, I guess like besides the risks there, I think that a part of the promising opportunities are also related to the fact that you're suddenly discovering new things, that you open up possibilities that if you weren't researching, then you may not have been able to find them. Yeah, that's I guess like my take on it. And yeah, it's very different environment to work in, right? Like you basically have no other option other than to just like embark on a research as a part of your development cycle.
Where are we right now at SpaceCoin? And what's your roadmap and timeline?
Okay. What's our timeline and roadmap is now we released the blue paper, and now actually we're looking forward to implement the part of the protocol to connecting the L2 on the ground and L1. So now actually we are in the stage where actually we are I would like say the booting up and demonstrate the snippets in the blue paper, and we'll iterating from there. So yeah, we are like just really on the early stage. We published the first phase of the research, and then actually we probably in 3 months we have like something more tangible where people can try it out. So we have like in the pipeline having the SpaceCoin dev kit, so people can actually have their very own the cluster, which actually is supposed to be like close to 1-to-1 what actually is running on the satellites, obviously. And then actually coming and collecting with the creative apps, which actually will benefiting running on the orbit rather than on the Earth. And then we are looking forward to getting more awareness, like as we demonstrate each of the use case. On the sidelines, we would like to release a demonstration of our cosmic entropy. So we would like to release this kind of the app where actually people can see it, like it's working and it's coming from the satellites. That's like one of the easiest thing. And then eventually for asset custody and other cases mentioned before. So yeah, we're actually quite small team, so we're rather looking forward to deliver one by one. But that's, I guess, hopefully that answered the question. And in the future, I think we haven't mentioned it here, but end of the December we will have like another launch on the 21st December, which will be the first the siege node, which will be like the part of the SpaceCoin V1. And then we're looking forward having like the secured like more launch slots for the next year, so we can slowly adding the capacity to the network.
That's exciting. So I asked this question because I can't wait to see it going live. Yes, but it still takes some time, right? At least several months to like for people can start maybe building something. Yeah.
I think some hardware is already assembled on the ground. I think just waiting to be launched up there. And our previous NORAD IDs are already available on the website to check on. But we probably will be expanding. We should like list some tracking system so people can see where the satellites are right now.
That would be helpful. Some cool visualization.
Yeah,
exactly.
Sandbox style environment that it's like mimicking what can actually be ended up being used. So that would be like a testnet scenario. Yeah, that would be much before we actually have all of the constellation launched and everything.
Okay, cool. Now I think we can bring up the last question. So please name a project that you are bullish about. You can have different answers.
Okay, I would like to give the props as we are building something cypherpunk. The guys from the Aleo and the Penumbra, they're actually building something really interesting and cool out there in the space. I think we've seen like I'm quite early in the crypto. I remember seeing the Zero Coin back then, and then obviously like the Zcash, and then there was like the tornado and these kind of things. But then actually people somehow focused on different level of the applications, the blockchain rather than privacy, obviously. But with all this, the privacy tech in the room is actually we should like have it much more, obviously, because they're actually open much more cases which what kind of application could be built. I know like value transfers is actually a good start, but then actually we can like incorporate much more variety of the apps then. And maybe Daniel.
Yeah, so we discussed it before. This was the hardest question for me to answer actually, because I'm bullish on so many things. At the same time, it's hard like to mention about. On the one hand, I'm like really bullish on privacy, and I hope that current trend is such that like tornado cash could exist, and like I used to be very bullish on tornado cash, so it's like not cool that it got hurt so much. Same time, I'd say projects that I feel are really interesting, not only from the tech, also from the tech point of view, but also because of like the spirit that they bring, scaling solutions like Mega ETH and Rise, that some people say that they're competitors, but I see them as like very much like bringing back that notion of a world computer, which I think is like a bit of a vision that was missing in the crypto narrative. So yeah, like these two teams I feel are really cool in that regard, Mega ETH and Rise Chain.
And then World Computer can collaborate with Space Computer.
Exactly.
That's your point. Right?
Well, hopefully one day.
Yeah, I mean, actually, we are talking to Mega ETH about a few use cases, so that's easy. And Sam from Rise Chain is also a mate, so he's Australian too. So, but yeah,
Oh,
just I really respect those teams. Yeah.
Amazing. So with that, Mate, Daniel, thank you so much for joining us today and sharing information about your journey and what you're up to. For those interested to learn more, we've added some links in the show notes. Finally, I want to thank Queenie for hosting with me. Until next time, thank you, everyone.
thank
Thank you.
you.